Hello, this is Mr. Precella, and today we're going to start looking at something called functions. And to be at something so important, it doesn't start off as a real rigorous thing, you know. Once we discuss functions, start them, that's all we're going to talk about the rest of the semester. Trigonometry is the study of 6 particular functions, the trig functions. Calculus 1, you study differential functions. 2, integrable functions. So from here on, once we define functions, pretty much all math classes after that involve functions. Okay? So what exactly is a function?
Oh, I don't know about linear algebra.
Okay.
Okay.
A function is a rule or correspondence, I'll say rule, which assigns to each x value exactly one, not 2 or 3, exactly one y value. So some sort of rule that assigns x values exactly one, or sometimes you'll see it say one and only one y value. The set of x values is called the domain, and the set of y values is called the range. So we have x's being assigned to y's, domain values being assigned to range values.
Let's look at an example of what is that?
Oh, is that problem 1?
No, it's something from the next section.
Oh, how the heck did it get that? Oh, look at how slow we are today.
The one over there, the processor, it's a new one, and it is very fast. So,
Oh, it is?
yeah.
Huh. Maybe we want to close it out and open it up again.
Once we get the first one pulled up, it should go quicker.
Can you zoom in a little to make it bigger? Plus. Okay.
And let me do that. What did I just do?
Close that. And right there.
Oh, there. Okay. What does this thing do?
It opens up the menu.
Oh, the homework over here. Okay.
Okay, so let's see. Problem number 1 says determine whether the correspondence is a function. And, oh, wow, it's sort of hard to see those numbers. So problem 1, let me write it down. We have a little table, and it's broken up. Domain, range. And looking at that with the arrows, it looks like the x value 10 is being assigned the y value of 6.
16 is assigned to 10.
Mm-hmm.
And 24 is assigned to 6.
And the question is this rule, correspondence, diagram, whatever you want to call it, a function? Is each x value being assigned only one y value, not 2 or 3? Like how many y values is the number 10 being assigned? Just one, that's 6. How many? What about 16? How many? Just one. What about 24? Just one. Is this a function? Is each x value being assigned exactly one y value? Yes, so this is a function.
I like to start off defining a function as a set of ordered pairs. So can y'all see the ordered pairs that are being generated from this correspondence here? What are the ordered pairs?
10, 6, 16, 10, 24, 6.
That's correct. Realize it's okay for y's to be repeated. You can have that 6, 2 different numbers for a sign 6. That's fine. But to be a function, you can't have the repeated x values.
Now back to number 1, to this one. What would have to be, how would it have to look if it were not a function? Well, I'm about to use
red pen.
okay. This red arrow I'm writing right here. If I drew a red arrow out of the 24 to the 10 also, then how many different y values is 24 being assigned? 2. So that would be not a function. Okay? If there were a red line or a second line coming out of any of these, then it's not a function.
So we say, yes, the way it was written, this correspondence is a function. Number 2. They're the ordered pairs. Okay, I should have known there'd be 1.
4, 5.
4 is assigned to 5. 27 is assigned to -6. 35 is assigned to 5. 4 is assigned to 7. And 47 is assigned to 7.
Oops. Okay.
I don't think you need to write this down, okay? I think they'll be able to tell me. Well, let's go ahead and write everything down.
It says, what's the domain? So,
When you're,
I need to look at those instructions once again.
Domain, range, is it a function?
But notice it says the domain is, use a comma to separate answers as needed. Type each answer only once. So if a number appears more than once, we're only going to type it once. So we'll go through and write out the the x values. There's a 4, a 27, a 35.
What else is in the domain?
47.
Another 47. You don't write 4 twice because you've already gotten that listed. The only other domain value is 47.
So why don't we write this domain range. Let me go ahead and write this down and then you can type those in.
And notice you're not typing the braces. They're giving you the braces. That's one of those things that people mess up on tests. They type the braces inside the braces. So be careful. What numbers are in the range?
5, -6,
and what else?
7. Notice how I don't type the 5 again, and I only type the 7 once.
If you accidentally say type the 7 twice, they'll tell you, hey, you're not supposed to type the same number twice. They do give you a warning message that tells you what you did wrong.
So let's go ahead and type those in before we answer the question, is it a function?
So the domain,
4, 27, 35, 47.
okay. And now the range,
5, -6, 7. Now, to decide if it's a function, I sort of like these arrows. Could y'all imagine drawing the arrows up right here? 4, 5, 27, -6, 35, 5, 4, 7.
what's happening there? 4 is being assigned to 2 numbers. So is it a function?
No, because right here, the number 4, it's this arrow here. Notice how there's 2 arrows coming out of the same x value. This is not a function. So the natural, the natural question is, can we look at this set of ordered pairs and answer, is it a function or not a function, without drawing the arrows? How can you look at this and say, okay, this isn't a function?
Looking at the ordered pairs.
Look,
7's repeated.
yeah. Notice, two ordered pairs with the same
X value.
x's.
The repeated y's are okay. It's the repeated x's that you can't have. Okay? Make a note. You cannot have repeated x
Is that
values.
legible? It says same x,
X
not
not
a function.
same x, not a function.
Now, if there's y values that are repeated, that's fine, and I'm about to write all of that out right now. That's right, what I was just saying. This is another way of defining function. So we got one way of defining it as just a rule. Here. A function is a set of ordered pairs in which no x coordinates are repeated. So let's say x values are repeated. So summarizing that, if there's repeated x's, it's not a function. Well, what about repeated y's? Can there be repeated y's?
Yeah, that's okay.
Yeah. Repeated y's are okay. It's the repeated x's that aren't functions. A week ago today, we graphed circles, if I'm remembering correctly. And so here's a question.
I remember the old Sullivan book used to have an assignment called one section, functions and circles. And I always thought that was strange. Okay. Are circles functions? Draw a circle centered at the edge.
I'm going to draw a, pretend this is my graph paper. I'm going to pretend that what I'm about to draw is a circle. I'm going to try to draw a circle with the centered at the origin with a radius of 2. So over here it would be at -2. Looks more like an oval than a circle, I suppose, but we'll just pretend. Okay. So I'm drawing a circle centered at the origin with a radius of 2.
Does that circle have repeated x values? What do you think? Yes? Look at the 2 where it intersects the y-axis. Give me the ordered pair representation for this point here, the point that I'm pointing at. 0, 2, okay. What about down here? Okay.
So repeated x's. So how would you answer this question? Are circles functions?
No.
Not functions.
And you can see that clearly because where that vertical line intersects the circle, you have the same x coordinate.
Now, there's nothing really special about the y-axis. Right here at 1, if we drew a vertical line, see, both of these green dots, the green might look black,
It does.
Both of these green dots have what number as their x value?
1.
One. So once again, repeated x values.
There's something called the vertical line test that you're going to want to remember. If you can draw a vertical line through a graph and it intersects the graph in 2 or more spots, it is not a function. And what I found strange was the way this textbook author combined functions with circles. And I remember some colleagues had some wild ideas about why he did that. And I said, no, I think it's because functions, his assignment on functions was pretty short, and his assignment over circles were pretty short, so he just put the 2 topics together. And people were like, oh no, that's not it. And they went through this highfalutin reason why he had combined the 2. Then the textbook was up for adoption, and the author was touring the country. He came here, to tout his book, and we were meeting with him, and I asked him, why did you put functions and circles together? And he was like, it was 2 short sections, so I thought it'd be better just to have one big section. I loved it because I was right. My co-workers were mad because they were wrong, and they voted not to use the book anymore. Can you believe that? We changed books.
This was way back in the
This was
olden
back in the
days.
olden
There's
days.
still a book to these things that y'all are doing here with Pearson. It's an e-book. You're not 96 or 97 years old. Our mother doesn't believe something can be a book unless it's on paper. She does not accept that, when I'm sitting there reading a book on my phone, it's not a book you're reading. Yes, it is a book, Mama. Okay,
And I
that's
just come in and I'll be like, oh, he's just punching on his phone, Mama. He's just, dilly-dallying on his phone. Says he's reading now. He's just punching on his phone.
You should be ashamed.
I should be ashamed.
Okay? But,
goodness.
so if a vertical line intersects a graph in more than one spot, it's not a function.
Okay.
So let's start looking at problem number. Look at
what
number
do y'all
3.
think? This looks like an absolute value function. Remember those V's? We even had an absolute value tool for graphing them. What do you think? Is the graph of an absolute value function, an absolute value expression a function? Will it pass that vertical line test? Can you draw a vertical line so that intersects it in more than in 2 or more spots?
I think this is a function, isn't it? Do y'all see there's a lot of vertical lines on it? They're the little grid lines.
Do any of those intersect 2 times? No? So what we conclude, is it a function?
Yes.
Yes, it is. Oops.
Here, look at
Oh,
this.
what happened?
Uh-oh.
Oh, I clicked no. Oh,
Uh-huh.
no. Oh, well, okay, it's another absolute value expression. Look at that V. What do y'all think? Is it a function?
Yes.
Yes, let me click yes this time. Oh, and by the way, when there's only 2 options, you only get 1 shot to select it, and if you don't select it right, then you have to say similar question and redo the problem.
So you get the green check mark. But look at, I made a note here.
Let me see.
Is a B a function? Yes. Okay, so that would be problem number 3. I think everyone's number 3 is just a V-shaped figure. And number 4, I think we may have already done that one.
No, this is an oval. We know that circles aren't functions. What do you think? Can you draw a vertical line to hit it twice here?
Yes.
Yes. And even ovals, ellipses, are not functions. Right here you can see that would be the point 0, 3. Down here would be the point 0, -3. So, not a function. Any questions on our logic there?
Number 5.
They can't all be that easy. Oh, well. Oh, okay. Here they want to know, is it a function? And then state the domain of range.
Oh,
Okay, draw the graph. I think maybe you should go to a new page. Okay. You can go back to use up that space on the shorter page. I mean, on the shorter problem.
I'm drawing a graph which isn't nearly as good as the one that's showing up on the screen.
So it looks like it intersects at -3 and -3.
Okay.
Although I'll tell you this much, any slanted line will have the same answer, okay? No matter if it's a slanted line, they're all either functions or not, and they have the same domain and range. So even if your graph isn't that accurate, Tony.
Yeah. For number 5, we're answering the question. We've already answered the question, are circles functions? No. Is a V shape a function? Yes. Is a slanted line a function? That's basically what we're answering on number 5. Well, if you
Draw a slanted line, vertical lines through that slanted line. Will you hit it twice? Will you ever hit that line twice?
The only way you could hit that line again would be if it turned around. Do y'all see that? If it turned around, then okay. Well, no, it'd have to turn this way. Okay, turn this way. If it turned like this, then yeah.
It would not be a function.
This turned like that. Then, so is a slanted line a function? Yes. Every
Always
slanted line is a function. Okay, so punch that in. And let's see how they want us to write the answer for domain and range. It says, what is the domain? Type your answer in interval notation.
It might be best to look at this graph
Yes,
right
I agree.
here.
Look at, blow it.
How about that?
Oh, that's good. Okay. Keeping in mind this arrow means it's going to this one right here. It's going to keep going left and up. And this one right here, what directions is it going to keep going? It'll be moving to the right and downward. So it looks like it's spanning from -10 to, what is that, 7? Well, if you can imagine continuing to draw this, and if we call way out here negative infinity, and way over here positive infinity on the x-axis, is this thing going to keep going and eventually have x values way over here at negative infinity? Yeah. And this is going to keep going. Well, eventually have x values way over here at positive infinity. It sort of takes a little bit of imagining, but I claim this thing just keeps going and going and going. Oops, like that. So it's going to, way over here, if we think of this as negative infinity on the x-axis, way over here is positive infinity. I don't want to waste the whole page by continuing to draw this. But way over here, there'll be points at positive infinity. So to say the domain of a slanted line, it's always negative infinity to positive infinity. That means it's eventually there's going to be part of the graph way over here on the left and way over here on the right. What about way up here? Way up at positive infinity, will there be points, y values there? Yeah. But if we continue going, will it eventually hit way down here at negative infinity? So what am I doing? A very poor job of saying the range is what?
Positive to negative.
Okay. Always write it in numerical order when writing interval notation. So you got to write it like this: negative infinity to infinity. And notice how I'm putting the parentheses. Remember, with with interval notation, you always put parentheses by infinity symbols. This is just a fancy way of saying all real numbers. Okay, this graph will have an x value for every value on the x-axis. It'll have a y value for every value on the y-axis.
All slanted lines are functions. Their domain will always be negative infinity to infinity. The range will always be negative infinity to infinity.
That's for a slanted line. Close that.
So parentheses, negative infinity, comma, infinity.
Years ago, we were at a Pearson conference, and they asked, "Is there something that we could do that that would make your life easier?" And I told them, make one little button that says parentheses, negative infinity, comma, infinity, close parentheses. And they just looked at me and acted like I didn't say anything. But
They never did.
and they never did add it or anything.
Just copy and paste it.
I know, but you can only copy and paste it.
If you've already typed it one time.
But
Yeah.
I don't think you can copy it now from that.
No, you have to do it before you type it.
I know, so if it's a problem number 5 only requires you typing
Okay.
negative infinity
Let's not
to
complain,
infinity.
Tony. It sounds like you're complaining.
And everyone knows which one of us is the complainer. Number 6.
I don't know where you learned to make infinity starting on the left-hand side. Do y'all do that? You start on the right-hand side, don't you?
No.
I cannot imagine where you learned to make an infinity like that.
I think
You start on the
most people start
left?
on the left, Tim.
Really?
You make it like this.
Let me ask you this, though. You start on the left. How many penmanship awards have you won?
Oh, gosh. Then I think most
Okay,
people
maybe.
start with the left. Like that.
Really?
Okay. Now let's see. I don't know if I feel like trying to draw this graph up there. First of all, it asks, okay, is
Is
this
it a function? Can you draw a vertical line to hit it in 2 spots?
Yes.
Yes, so what does that say? Is it a function? No, it isn't. Okay.
Now, here comes the good part. What is the domain? Why don't you try blowing it up the way you did a while ago?
Is every number on the x-axis used as an x-coordinate? Say here's -3. Is there a point on the graph that has -3 as the x-axis?
There's a definite starting point on this graph. What's the smallest x value?
-1 is the smallest x value. There's not a point on the graph that has -3. So the domain is not going to be all real numbers, negative infinity to positive infinity. The smallest x value is -1.
And what's the biggest x value? We see that it goes all the way up to 10, but is it going to keep going?
It's going to keep on going, isn't it? So every x value to the right of -1 is going to be used as an x coordinate. Even way out here at 1,000,000. Yeah, there'll be a point up there. There'll be 2 points that have x coordinates of 1,000,000. So how can we say that? The smallest x value is -1, but then it just keeps going and getting bigger and bigger.
Brackets of -1.
Bracket on the -1 because there is actually a point at -1.
We're using a bracket because you're right. There is a point at -1. There it is. But how do we say the x values keep going and going forever and ever, getting bigger? Positive infinity.
And what am I going to put there? Parentheses or bracket? Parentheses. Always parentheses by infinity symbols. Wow, that looks bad. You want to type that in?
I sure do. Let me close that off. So we have a bracket, -1, comma, infinity, parenthesis. There's not really any work here, just looking at the graph and trying to analyze it and determine what x values are used. What about the y values? Now we're ready for the range.
Is this thing going to keep going up and down? Does it go up forever? Because if it does, then that means that it would be going up to infinity. And is it going down forever? I remember a student once telling me that they think that the graph's about to stop and turn around. No, don't assume that.
The
Okay.
arrow is going up,
It's
so
going to keep going up slowly. It's going to keep going down slowly. Will it eventually hit the, if it keeps going and going and going, will it eventually hit the roof? Yeah. Will it eventually hit the floor, this part right here? Yeah. So what am I doing a very poor job of saying? The range is?
Negative infinity and positive.
Yeah, negative infinity to positive infinity. We were mirror twins when we were born. I think that might be why you're.
I start on the right.
Yeah, I bet if someone with those left-handed makes it like that.
You think that accounts for my good penmanship also?
Well, the teachers did have to teach you to write with the right hand.
They only had to tie my left hand down twice.
Oh, okay.
Okay.
Back in the olden days, they knew left-handed people are weird. We don't want to be left-handed. Now, of course, scientists know, oh, wow, left-handed people are the people that
Achieve power. They
Achieve
strive
power.
for power.
there's more right-handed than left-handed, right?
Right.
90% to 10%,
Is it
right?
really?
Yeah, it's a
Something
One of my
huge
teachers was
10%.
left-handed.
But there's a lot more left-handed presidents of the United States than right-handed.
Why are there
Left-handed
so
people
many left-handed?
Ascend to power. Fortunately, they trained him to use his right hand.
Yes.
So he's right here, not trying to climb to power.
Oh.
You see, and here's one of those times I would have liked to just have a button to click.
Oh,
Parentheses, negative infinity, comma, infinity.
Negative infinity, comma, infinity. Any questions there? Let's see this. Oh,
Oh, wait.
we need to talk
What?
some more.
You want to talk on this?
Okay, yeah, I'll take it again.
We're about to start. So at this point, we've seen functions as little correspondences or diagrams, and we saw them as graphs,
Ordered
and we
pairs.
saw them as ordered pairs, right? And now I'm going to state the algebraic definition of function. So we'll have three definitions of functions. It could be a rule of correspondence, it could be a set of ordered pairs, or let's see, here's our algebraic definition of function. A function is an algebraic equation the equation has an equal sign that assigns each number in one set, the domain, and this one set is called the domain, to exactly one number in another set. And we know what that other set is called.
the range. Okay, so I just now defined three terms: function, domain, and range.
Written all of that, and you could have just said for number 7, plug it in.
I'm not even through talking yet, Tony.
Oh, okay.
Okay, let's break this definition apart. A function is an algebraic equation. Well, I know what an equation is. An equation has to have an equal. 1 plus 2 equals 3 is an equation, but it's not an algebraic equation. What does it have to have in it to be algebraic? When did you switch from arithmetic to algebra? Be more specific.
Yeah.
Okay, letters. When letters started appearing in the math problem, that's when you switched from arithmetic to algebra. For domain values, the most frequently used letter, since it's the ordered pair definition, it's the x coordinate. What do y'all think? What letter is the most common domain variable, you think? No, for domain, the most common variable is x.
Yeah.
But you can use any letter. I use T for time. I'll use Q for quantity. You can use any letter you want to, but the most common domain variable is x. As for range values, what letter do you think is the most common variable used for range values? That's the y value, but once again, we can use anything. I use C for cost functions. I use R for revenue functions. I use capital P for profit functions. It could really be anything, but as I said, the most common range variable is y. The most common domain variable is x. There's something called function notation. With function notation, now with function notation, the equation has to have been solved for y first. The equation must be solved for y. And then if the expression represents a function, we will replace y with f of x. F left parentheses, x right parentheses. That's not f times x. That's read as f of x or function of x. When you see this notation appearing in an equation, that's telling you it is definitely a function. That means each x value can create one and only one y value. And let's look at numbers 7 to illustrate function notation. Find the indicated outputs for f of x equals 3x squared minus 3x. Let me write the problem down. This is number 7. The function is f of x equals 3x squared minus 3x. And they want us to find the indicated outputs. I could have said find the indicated y values. I could have said find the indicated function values, but they're calling it outputs.
So to find f of 0,
Look at
I said plug it in.
Now, this notation, look at this notation. f of x equals 3x squared minus 3x. Notice f of x is by itself. I said the way the equation has to be solved for y, and then y is replaced with that notation. F of x is taking the place of y. You can't have 3f of x, or 3f of x squared minus 3f of x. That y has to be solved, and then the f of x is by itself. This notation, they want us to find f of 0. That says go to the function f, and wherever you see a variable, replace it with what's in the parentheses. So everywhere you see a variable here, we're going to replace it with 0. Well, we call your order of operations. You perform the exponentiation first. 0 squared is 0 times 3 is 0 minus 3 times 0 is 0, to give me a final answer of 0. We just created an ordered pair with that function machine concept. We dropped the 0 into the function. Oh, and well, it didn't do much change. It gave us back a 0 as the y value. We just created the ordered pair 0, 0. Type in the 0.
X, Y.
When x is 0, y is 0. What about f of negative 1? F of negative 1. That says go with function notation. You go to the function f, and wherever you see a variable, we're going to replace it this time with negative 1. So replace each x with negative 1. Okay, let's simplify this. What did we do? What will we do first to simplify this? Negative 1 squared. Negative 1 times negative 1 is? 1 times 3 is 3. Minus. Now, minus 3 times a minus 1 becomes a what? A positive 3, to give us a y value of 6. So negative 1 is assigned to 6. We just created an ordered pair. Negative 1, comma 6. These function equations are just ordered pair generators. You give me the x, I'll plug it in and tell you what the y value is. F of 2. That says go to the function f. Everywhere you see a variable, replace it with. What is f of 2 telling us to do? Okay, we're going to replace every x with 2. We perform the exponentiation first. 2 squared is 4 times 3 minus 6. 3 times 2 to give me a final y value of 6. So if we plugged in 2 for x, we get the y value 6. They don't ask you to write these as ordered pairs, but realize what you just created is the ordered pair 2, 6.
Or in terms of the little triangle, the little arrow thing, 0 is being assigned to 0, negative 1 is being assigned to 6, positive 2 is also being assigned to 6.
Let me ask you something. Is it possible that I plug in 2 and get 6, and Tony plugs in 2 and gets some other number, and we both be correct? No, because for every x value, you know it's a function. They told you that with that f of x notation. You know it's a function, so for any x value, there can only be one y value. Did you type in the answer?
I don't think so.
Okay, next question. Here's another. Notice they're using the letter K here instead of
The most
F.
common
How about
letter used for functions is if, because the word if
function starts with
the word function starts with the letter if. But you could use any name for a function. So this is number 8. And this is k of x is equal to x plus 2. And they want us to find, okay,
I think we can
k
do
of
this one
0.
if you don't have to write it down.
Okay. K of 0, that says go to k, replace every variable with a 0. With a 0. What are you going to get? 0 plus 2 is 2. So we can do that without writing anything down. The next one, k of negative 19. That says go to k and replace every x with. We're going to replace the x with negative 19. Negative 19 plus 2. What are we going to get as our y value? Negative 17. So negative 19 is assigned to negative 17. Whatever's in the parentheses, that's what you replace the variable with. K of negative 2.
I think they can do it without writing it down.
That says go to the function k and replace every x with a negative 2. What are you going to get? Negative 2 plus 2, I agree with 0.
Any questions there?
What about k of 9? I'm going to write this one just as when I don't write something, I feel like I'm not doing my job. So what is it, k of 9?
9.
That says go to your function k, replace the x with 9. What's that going to give me for the y value? 11. Good.
Notice how every x value is being assigned only one y value.
It's impossible for me to plug in a 9 and get 11. Tony plug in a 9 and get 12, and we both be right.
Okay, so it's got to eventually get harder.
I've told them what you have to do. They know how function notation works. Look at that.
Whatever's in the parentheses, you plug in for x. Isn't that what we're doing?
You come up here.
Oh, let me show you what, since you're pointing.
Okay.
Okay.
Okay, we're going to replace x with what? C plus 17. And we can simplify that. The 17 plus 2 becomes 19, so the y value is c plus 19. Any questions there?
Whatever's in the parentheses, you plug in for x, even if it looks strange. So it doesn't have to just be a number. You could be plugging in a variable expression.
Here we had to change a variable from x to c. Change the constant too.
So it's c plus 19. Any questions? Here's another one. Okay.
Number 9.
Notice they're using the function g. And it's g of x equals 10x. Why don't you just write down all three?
I intend to. So we want g of. I guess I'm confusing. G of.
Negative 4, 11, and 28. So writing down the question. Okay. What will we do on to find g of -4?
That says go to your function g, and wherever you see an x, replace it with. So instead of 10 times x, we're going to have 10 times -4. What's that going to give us for our y value? -40. 10 times -4 is -40. What about g of 11? That says go to your function g, wherever you see a variable, replace it with 11. So 10 times 11, is that 110? For our y value.
We'll just wait and punch all three of these numbers in. Stop all this.
Last one, g of 28. That says go to your function g, wherever you see an x, replace it with 28. And 10 times 28 gives me a y value of 280. -40, 110, and 280. Any questions there?
-40, 110, oops. And 280. Okay. Let's see. Another one.
Okay, let me put this one
Go ahead
down.
and write it down. So this is one of those that's not going to have any work to show. It's just going to be write down the problem and punch in the answer.
It doesn't hurt us to write it
I know.
down, Tom. But then again, you're one of those people that reads books on their telephone, so I suppose you don't value paper. You need to remember, we're timber farmers in East Texas. We own some land that our parents gave us, and in order to cut down on the taxes, if you declare it tree farming, there's a huge tax exemption.
You only pay taxes on half an acre, actually.
So that's the exemption. So we designated it tree farming. So we are tree farmers.
The trees are just growing there, getting taller and taller. I don't want to cut them down. No.
I remember when we clear cut that land. Was that 78?
78.
No, I could swear it was 78.
It was
We
so
were very
lovely.
young, and our father owned a timber contracting business. So,
He was between jobs and decided he'd cut down our timber.
and you think to yourself, oh, we're just going to have this beautiful pasture out there. But the phrase raping the land exactly describes what happens when you go in there clear cutting.
When you go into a forest and cut down all the trees, you don't take everything. The limbs they cut off. They
So-
take the trunk of the tree. It was just a mess. It took years. So no, I don't want to. Every day we get letters, literally letters in the mail from people wanting to cut our trees.
They call it harvesting.
I call it raping our forest. I throw it away. I throw those away. Okay, have we talked long enough?
Is
Whatever's
someone
in
gonna
the parentheses, you plug in for X.
So what's the answer going to be?
-5 plus 6.
That's right. You just go up there. It's strictly a change of variable. Everything else stays the same.
-5n plus 6. My dear graduate advisor, I remember her once telling a class,
F
Like-
of cat.
Yeah, f of cat, it'd be negative 5 cat plus 6. Whatever's in there, you just plug in for x. Turns out she hated her job. Who knew?
For all that goes
So, negative,
That's a
5,
funny question.
yeah.
I'll tell you the answer at the end of the video.
well, what's classes?
I mean, what's class is that?
How many more of these do we have? Oh, wow. So, okay, now this one we got to write down. But in words, what are we going to be replacing the x with here? Have any idea? The 2b minus 3. So in place of the x,
Two.
you got to
switch
put
to
what's
my
in the
paper.
parentheses.
So this says, go to your function f, and wherever you see a variable, replace it with 2b minus 3, and realize that 2b minus 3, since it's more than one term, I'm enclosing it in parentheses. What are we going to have to do to simplify this? There's only one correct next step. Okay, so you're taking that negative 3 and distributing it there and there. Negative 3 times 2 gives me negative 6b and positive 9, I agree. And we still have what's stuck on there,
Plus 5.
the plus 5. And we can combine the 9 plus 5, that's a 14. Negative 6b plus 14. And that's a b, not a 6.
Oh, yeah. Negative 6b plus 14. Y'all caught up? Any questions?
Let's go back. I want to go back to something. Let me see what number 11 is.
Oh, that was 11. We're number 12.
Oh, number 12. Okay.
You already done number 11.
No, yeah, I said the wrong number. Okay, let me write this problem down.
So notice here, instead of being given the equation, we're just given ordered pairs.
The way I've been saying, when x is 2, y is what?
Wait, they don't see what you're pointing at.
Here in this example, when x is 2, y is 6. We created an ordered pair, 2, 6. So with that in mind, keep that in mind. If you understand that, then this next one's going to be real easy. And is that 3, negative 6? And they want us to find f of 3. I think I heard it. When x,
Oh, wait, let me show what you're writing.
when x is 3, what's the y value? When x is 3, the y value is negative 6.
Do y'all see why the answer isn't negative 4? The number in the parentheses is x.
What is the y value? Remember, the function value is just a fancy way of saying the y value. So when x is 3, the y value is negative 6. Is there another part to that?
No, but pretend that there's a part f of negative 4.
Okay, what about this? F of negative 4. 3. When x is negative 4, the y value is 3.
And let's pretend there's one more part.
Okay.
F of negative 1.
Okay, f of negative 1. When x is negative 1, the y value is, I couldn't hear you, 6, I agree.
See,
I'm going to add
these
another
have
part.
to be the x values. This over here must be the y values.
Okay, I'm going to add another part. One more part. f of 7.
Is there an x value of 7 up here? So you say, what are you going to write?
I'm going to say
Not defined.
not defined. 7, is 7 in the domain? No, you see, I was going to say 7 is not in the domain. I'll just say not defined. Because 7 is not in the domain.
In other words, because there's no ordered pair with a 7 as the x value. I don't remember, did I picture -6? That's the only part of this problem. Did I get it right, or have I not done that yet? Oh, nope, I haven't. -6. So, the number in the parentheses is x. Your answer is y. I remember once, this was way back in the old building where, wow, I spent like 45 minutes on this question. I thought everything was going so good that all of a sudden,
You must have done
I
an
just
exceptionally
poor
poor job
job.
of explaining
I know.
the material.
Gosh.
If this took a long time.
it did.
Here's the graph.
But
Look,
once,
first of all, we want f of -2. Oh, I don't know if I'd even try to draw the graph here, okay? Because
why don't you blow it up so we
I'm
can
gonna-
see it better? So,
I want f of -2. The x value is -2. What's the y value? You're analyzing the graph. For f of -2, that says x is -2. What's y?
what point am I looking at on this graph?
0.
Okay, there it
Right,
is.
negative
When
2.
x is -2, the y value is 0. So I'm going to write that down. I don't know why. Let's go ahead and type in.
Oh,
We're going to have to keep on.
0.
Okay, part B is f of 0.
Maybe if I do this.
Yeah, that's better. There. F of 0. When x is 0, what's the y value? 4. Well, where are we looking? We're looking right here. When x is 0, you go to the graph, the y value is 4. So we're going to punch in 4. Part C is f of 1. When x is 1, what's the y value?
So move the cursor back so I can see where you are.
Okay.
Is it 2?
When x is 1, the y value is 2. I agree. Well, how do you know it's not 1.999999? Something that looks just like 2. Well, you don't. You just have to assume it's going to be an integer. One more part, f of 4. I'm not going to say anything. When x is 4, what's the y value? I think I said it. Yeah, when x is 4, the y value is 4. Any questions there? You should be able to analyze function notation, whether they give you an equation, a set of ordered pairs, or a graph. You're just determining the corresponding y value. Any questions there?
And years ago when that was so much trouble. Because there was one student having trouble, and she was able to get the whole class having trouble and with this problem. And she finally said, well, what I want to know is how to do it. I'm not looking at the graph. I was like, well, you got to look at, she wants to know how to do it if there's not a graph, if they don't show the graph. Well,
then they give an equation or a set of ordered pairs. But for this problem, there's a graph. Any questions there? Suppose I'd asked for f of 3. I'm going to quiz you.
What's f of 3?
Oh. What would f of 3 be using that graph? Can you tell?
2.
I think it's a 2.
Yeah.
Any questions there?
What about f of 1? F of +1 would be,
We've already answered that. What about
we
f
have.
of -1?
Ooh, negative.
One is also 2.
Oh,
Negative
it's
one
another
is also
2.
true.
Okay.
Any questions there?
Let me see. What's number
Okay.
14? Is it?
I think we're about to
Okay.
begin the biggie.
Okay.
Okay. The whole point of this thing. Switch over here.
Okay.
Let's look at number 7. They had us plug in 0, negative 1, and 2. Don't write this down. I'm not going to write down
You've already
anything.
written it down.
But
What do you mean don't write it down?
suppose I'd asked, find f of a million. Could you do that? Do you know what you'd have to do if they said find f of a million?
Yes.
You'd have to plug in a million for those x's. Suppose they'd asked you to find f of 1/3. Could you do that?
Yes.
You might not
plug in
want to.
You might not
but
want to, but you can do it.
you can plug it
And
in.
so, when you're finding the domain of a function, we're going to assume they mean find all the numbers that when plugged in for x, give us a real number back for y, unless they tell us otherwise. In the math for business and the calculus for business, they'll frequently tell you, oh, just assume x is greater than or equal to 20. This cost function doesn't work unless production is at least a level of 20. So sometimes they may tell you the domain, but unless you're told otherwise,
So what we're about to start doing is how do you find the domain of a function when it's written as one of those formulas or equations?
Well, we
whatever.
know how to find the domain if it's written as an ordered pair, or if it's a graph, you look and ask, does it keep going and going forever? Or the arrowheads and stuff, if so, which way is it going forever, left, right, up, or down? But with an equation, unless told otherwise, assume the domain is the set of all real numbers comma, that when plugged in for x, oh, that sounds so sloppy, when plugged in for x. Maybe I should say substituted for x. Comma, produces a real number for y. It's the set of all real numbers that, when substituted for x, I think that comma should have gone after that, that produces a real number for y. Comma, not an imaginary number and not an undefined result. So if you plug in 4 and get 2i for a y value, that's unacceptable. Not an imaginary number and not an undefined result. There are 2 huge things that you have to avoid when finding domains. When you create an imaginary number, we haven't seen a single imaginary number today. Think about imaginary numbers. When do imaginary numbers occur? What is I equal? Not -1. There's more to it than just a -1. The square root of a -1. If you're going to produce an imaginary number, you have to have a square root appearing so that you plug in the negative number underneath it and you wind up with an I. So you've got to avoid. There are 2 huge things you have to avoid. You have to avoid the square root of a negative number. You don't want square roots of negatives.
I remember discussing when something was undefined. When did we get undefined results? When was the first time divide by 0? So here's the other thing you want to avoid. You're dividing and get a denominator of 0. Those are the two things you want to avoid. Now, if you're going to pick up imaginary numbers, your equation is going to have a square root appearing. If you're going to pick up a denominator of 0, the equation has to have a fraction bar with a variable down there in the denominator where you can plug in something to give you a denominator of 0. Look back at this number 7. Look at this number 7. Will you ever pick up square roots of negatives? No, because there's no square root symbol up here. What about a denominator of 0? Will you ever pick up a denominator of 0? No, because there's no what? There's no denominator appearing. If your function has no square roots, no fractions, unless they tell you otherwise, assume the domain is all real numbers. So, no square roots and no fractions, unless they tell you otherwise, assume the domain is negative infinity to infinity. Actually, I start in the middle, don't I? I don't start on the right. I start right there in the middle. Ah. Let's do number 15 first. What is the domain? Let me write it down. Number 15, here's the function. F of x is equal to x squared minus 7x plus 5. Okay, let me switch over. First thing I always ask myself is, are there any square roots? Is this going to produce any imaginary numbers? And the answer is no. Are we going to get any undefined results? The answer is. So what do you assume? Unless they tell you otherwise, the domain is negative infinity to positive infinity. All real numbers. Any questions there? Functions of this nature, well, that's a trinomial, but in general, we refer to those as polynomial functions. The domain of any polynomial function is all real numbers. So number 15, we select, looks like it's D, all real numbers. Any questions there? Now I want to back up to number 14. Let me write down the function f of x is equal to 2x, just 2 over x plus 12. I want us to find the domain. Find the domain. What numbers can we plug in for x and get a real number back for y? The first question, will this function produce imaginary numbers? In order to produce imaginary numbers, you have to have what? A square root. Do you see a square root there? No? Okay. Will it produce undefined results? Yes. We know when a fraction is undefined. When is a fraction undefined? Okay, so we don't want that denominator to be 0. So x plus 12 cannot equal 0. Treat that not equal to as the same way you would if it were an equation. What would you do to get x by itself? Minus the 12. So we don't want x to be negative 12. So we can't plug in negative 12. That's saying you can plug in any number you want to, except you can't plug in negative 12. Could you plug in 12 million? Yeah, you could plug in 12 million. Could you plug in pi? Yes, you just can't plug in negative 12. I used to like it when we wrote it out in words. The domain is all real numbers except, what's the one number that's not used? Negative 12. But we don't do it like that anymore. They want us to write it using interval notation. Now, how would we say that? Every number except for negative 12. Think of a number line. For this first time here, let's think of a number line. There's negative 12. It can be anything except it can't be negative 12. Think about those the denominator cut points. By the way, when using the cut point method, we have the solution cut points and we have denominator cut points. The formal name of the denominator cut points is domain cut points, but we haven't defined domain by the time we do those. So that's why we call them denominator cut points. But in reality, we found a domain cut point, negative 12. How would we label those? Do we want the denominator to be 0? No, so we put an open circle there. But we can use anything else. We can use all these numbers to the left. We can use all these numbers to the right. What's the only number we can't use? Negative 12. How do we say this using interval notation? How do we say the numbers to the left of negative 12? I'll get us started. Does this thing ever end out here? So that's a parenthesis, negative infinity, comma, negative 12. What do we put after the negative 12? Another parenthesis. You're not including negative 12. Or x can be any number bigger than negative 12. How would we write that? Call it out as if I were typing it in. Parentheses, negative 12, comma, positive infinity. What goes after the positive infinity? Another parenthesis. This is saying all the numbers to the left of negative 12. This is saying all the numbers to the right of negative 12. The only number that's not included is negative 12. And I wanted an interval notation. Unfortunately, it does sort of hide what you're really saying. You can plug in any number you want to there, except for negative 12.
It sure be nice if they wrote it out in words instead.
But they don't. So let's keep going.
My sister knows very little algebra, but she can read all the numbers except negative 12. Well, okay. But this, I know she knows that's an infinity symbol, and she could read it out, but she wouldn't know that it means everything except negative 12, right?
No,
I'm just picking on Monica because she doesn't know a lot of algebra, and, back in the olden days, we used to say, when you can, write it in words so someone can read that. And they may not know what you mean by a real number as opposed to an imaginary number, but they could at least read it. Here, what the heck does that mean?
But that's what they want.
Okay.
Let's go on number 16.
16? Oh, you've already done 15. Okay, 16.
Okay. Let me write it. Oh, okay, let me write this problem down. Then I have a question for y'all.
Set at x minus 2.
X plus 2.
X plus 2. Okay. Switch it. I'm going to find the domain.
Well, we know for a fact that the domain is not negative infinity to infinity. Why? It's fractions.
Okay. Let's look at number 14 before we go on. Look back up here. Suppose I did this. I'm going to change number 14. Suppose I changed it to 2x plus 1. Does that change the final answer? Does that change the domain? Y'all should have told me I didn't box in my answer.
And you didn't do it here either, Tim. Oh my gosh.
I'm doing it. Don't worry.
Oh gosh.
Don't panic yet. Would that change? Would changing the numerator change the domain? Is the numerator used when determining the domain in this situation? No. A function like this, that's a fraction, is called a rational function. Just like a rational equation is an equation with fractions. A rational number is a number that's a fraction. So all we're using are the denominator. First question, will this thing produce imaginary numbers? And the answer is no, it won't produce imaginary numbers because there's no square roots. We're going to get there. Probably the next one will have a square root appearing, but for the time being, still no square root. Will it produce undefined results? Yes. In this case, we have two denominators. We don't want either of those denominators to be 0. X plus 13 can't be 0. X plus 2 can't be 0. So that means this first one, x cannot equal negative 13. The second one, x can't equal. So could x equal 50? Could you use 50?
Yes.
Could you use 50 million?
Yes.
What are the only two numbers you cannot plug in for x on number 16?
Negative 13.
Okay, so the domain is all real numbers except for negative 13 or negative 2. I'll say, I'm going to write it out in words. This is the last time I'll do that. All real numbers except negative 13 or negative 2.
People that have done this a long time sort of dislike the fact that all of a sudden you've got to write everything in interval notation. Dr. Kirkendall retired in May 2020. He had been teaching here for 48 years. I tried to get him, stay 2 more, get 50 years. But he was over 70. He was ready to go. 70. He was ready to retire. Yeah.
Not ready to go.
Yeah, ready to go. Leave Delmar.
That's
He's ready to retire. But, and I mentioned him because I saw one of his tests one day. He showed it to me. He thought it was really funny. It was a paper test, and he had written up, a problem like this, find the domain, and then he wrote, do not write the answer in interval notation. He wanted him to write it out in words like this. He was sort of tired of all this interval notation.
So let me see.
Y'all see the interval notation in your head? Draw the number line, put open circles at negative 13 and negative 2.
So think about remember which one is bigger, negative 13 or negative 2? Negative 2 is bigger, so it goes to the right. There's negative 13, and we don't want those numbers.
But we want everything else.
I just got to
This is
disagree with
multiple
you.
choice.
Dr. Kirkendall retired in May 2019.
Oh, yes, it was before the pandemic. Before we moved into this building. You're right. Oh, my gosh. It's been what?
So
Almost
what did
5
you say?
years.
It's open circle again?
Okay, so
Are we using the number? Do we want a denominator of 0? No. So you always think back to the steps for the cut point method. Denominator cut points you always label with open circles. You
Okay,
do not
that's
want to include those.
Thank you.
Okay? How are we going to say the interval to the left of negative 13? Here's all the numbers to the left of negative 13. How do we denote that using interval notation? Remind you that there's a negative infinity and that's a positive infinity. How do we write the first interval?
Open parentheses, negative infinity, comma 13, close parentheses.
Okay, negative 13. Or, union, how do we say the numbers between negative 13 and negative 2?
Parentheses, negative 13, comma, negative 2 parentheses.
Okay. Or, how do we say the numbers to the right of negative 2? Parentheses, negative 2. Okay. Where's my, why did I forget about my green pen?
Good. But on the screen, the green looks black to
Yeah,
me.
it does.
Mm-hmm.
Does it look like that on the videos?
I know people are always saying, oh, back in the olden days, the students were so smart and all of this and stuff. But back in the olden days, you stop here. So y'all have a whole new thing to worry about. Oh, now we got to write it in this little secret language that only a handful of people look at that and know that means, that means all numbers except negative 13 and negative 2. So let me start typing it in. Oh, no, it's multiple choice.
Oh, okay.
But there is one that it'll be where you have to type it in. I think the very last one.
I should have been true.
Oh, okay. Now, move on to the next one. There's got to be one with some square roots. Okay.
Compare 17 and 18.
Yeah, look at 17 and look at 18. Because I'm going to tell you two different ways to do them. They both have square roots, but one of them has the square root in the bottom of the fraction. And one of them doesn't have a fraction. Okay? So I'm showing you how to do number 17 first. This is how to find the domain of a square root function if there's no fraction. Okay? Let me write it down. Number 17. F of x equals the square root of 20 minus 2x. Okay? I think I'm going to go ahead and write down number 18 also. I should have doubled that. I should have drawn a line and put 18 over here so y'all can see the difference. No, I won't, but that's what I should have done. What was number 18? 1 over the square root of x minus 12. Okay. So 18 has the square root in the bottom of a fraction. 17, no fraction at all. With a square root, we can't have a negative under a square root symbol. Remember, if you take the square root of, say, a negative 4 on your calculator, it's going to say non-real answer. These calculators don't work with imaginary numbers. Is it okay to have a 0 under a square root? What's the square root of 0? 0. Square root of 0 is 0. That's perfectly fine. find the square root, or to find the domain when there's a square root and no fraction, you're going to think to yourself, okay, everything under the square root symbol needs to be greater than or equal to 0. Like if 10, x were a 10, we'd have 20 minus 20. That would be fine. We'd have a square root of 0. So how do we solve, well, let's look at this one. I'm making a huge mistake. I thought I'd set them both up at the same time.
I thought you should. That's what I was going to do.
On
I'll take over
how
now.
is this problem going to differ from this one? Over here I said that the stuff under the square root can be greater than or equal to 0.
Because the square root of 0 is 0. It's a number.
This can't be 0. So if it's like number 18, you're going to solve x minus 12 is just greater than 0. So if you're finding the domain of a square root function, you're going to wind up, what's the name of the process we use to solve inequalities?
I was just mentioning it about
Cut points. So we're going to have to do cut points on both of these. But is it clear you put the equal sign when there's not a fraction? Because it's certainly fine to have a 0 under a square root. It's not okay to have a 0 in the bottom of the fraction. If we hadn't had the 1 over, if it had just been square root of x minus 12, we'd have an equal sign here. Okay? So let's solve this one, the top one, using the cut point method. And it might be difficult to you because you've never used or solved a cut point method problem that's this easy. You start off putting an equal sign. This is what we call the solution cut points. And how would you go about solving this for x? I think I'm going to avoid negatives by moving the 2x over. And then doing what?
Divide.
Divide by 2. So we get x equals 10. With solution cut points, you look up here. Open or close circle. Closed. So you're going to draw, that's your only cut point. So draw a number line. Plot the 10 with a closed circle. And test one side. Doesn't matter which side. Or what number you use. What number do you think I'm going to use? 0.
Which
0.
side has 0, the left or right? The left? Okay.
0 is between a negative and a positive. 0 is never between two positives. Now this symbol right here,
That's positive. You put a
it
negative.
looks like I put a negative
Put it
there.
a positive. Make it
I'll make it a positive, okay. But it was really just the way I started
If you started in the middle the way I do,
then that
would not have happened.
So I'm testing 0. So 20 minus 2 times 0 is just 0. Well, it's certainly not equal to 0, but is it greater than 0? Yeah. So shade here, cross out there.
And if you don't believe that has to be crossed out, plug in 11. 20 minus 22, is that greater than 0? No. So you should be able to convince yourself if this side is true, the other one over there has to be false.
So how do I write this in my interval notation?
Call it out as if you were typing it in.
Close parentheses.
Parentheses,
Negative infinity. 10.
And what goes after 10?
Bracket.
Bracket. Good.
Mm-hmm. Negative infinity to 10. Now, this one is not multiple choice.
Click. Left parenthesis, negative infinity, comma, 10, bracket.
So that means every number to the left of 10, including
Including
10. If this were on Dr. Kirkendall's final test, he would have, he would have wanted you to write all numbers to the left of 10, including 10.
Could we plug in 20? Would 20 be okay?
No.
No,
Because
because
that's-
20 minus 40 is negative. You can only use 10 or numbers smaller than 10. Now compare that to number 11.
The big difference is you have an equal sign here when there's no fraction. When it's got the fraction like this one, is it clear why there's not an equal sign?
If the square root is in the denominator, you just use a greater than. If the square root is not in a denominator, greater than or equal to.
But then it's a simple cut point problem. So let's see. I'll start off with just x minus 12 equals 0, those SCPs. So x equals 12. Open a closed circle. Open. Draw a number line. Label 12 with an open circle.
You could probably do the checking in your head.
Bet I could.
I bet he could. But I think you should show it. What number do you think he's going to test? 0. Okay, 0 is in the left interval.
0 minus 12. Is that greater than 0? No, that's a false.
It should be obvious if you tested 13. 13 minus 12, yes, that's greater than 0.
So what are we going to type in as the...
Call it out as if I were typing it in. Parentheses.
12, positive infinity.
Okay. Hmm.
Any questions on our logic there? If the square root is in a denominator, you set the thing under the square root greater than 0 and use the cut point method. If the square root is not in a denominator, greater than or equal to 0, and use the cut point method.
And the cut point method itself falls out a lot easier than any cut point you've done this semester, okay? Notice just one cut point.
Oh, we don't have to type anything.
Yeah, but the next one we're going to have to type.
Okay, which one was it? D? Oh, look at that. Is it B or D? Which one?
Maybe they can't. Those are mighty hard to see.
Okay, hold on. Oh, I went to
this up.
Yeah, hold on.
There. Okay, wait. Show B and D. It is.
Okay, there's B and there's D. I nearly clicked D. Was I right?
Oh.
No, it has to be B. Okay, that's right. Let me shrink it back down.
And the last problem, number 19. This is one where there's no review or anything.
Find the domain. I don't know why they stick on that do not use a graphing calculator, but
If you do use a graphing calculator, show me what you did to get the domain.
is this thing going to produce imaginary numbers? Or we have to use the cut point method here? Will this produce imaginary numbers? No, because there's no square root. Will it produce undefined results? Yes, because I see a
Denominator.
I just put it here. So we don't want the denominator to be equal to 0. Let me switch over.
Okay.
You've got it written there.
Okay.
Ah,
Oops. Okay, so the denominator can't be 0. On number 16, it was pretty easy to figure out these because there was no exponents. what am I thinking I'm going to have to do here with this? Starts with the F. Factor it. Is this one we're going to be able to factor without too much trouble? X and X.
What do we know about the signs?
Plus minus.
Plus and minus. Y'all hear Abby? 1 times 8 or 2 times 4?
1 times 8. It's a simple trinomial. So in this case, we have to choose the pair of numbers that subtracts to give us 7. So where's the plus going to be and where will the minus be? Minus 8 and a plus 1. Let's check. The outer product is negative 8. What's the inner product? Okay, so negative 8 plus 1. Sure enough, that gives us the negative 7 that we need.
So X plus 1 can't be 0. Isolate X. X minus 8 can't be 0. Isolate X. So we get X can't be what? Negative 1 or positive 8.
Could I plug in 50 million?
Sure.
Yes, I could. What are the only two numbers I cannot plug in for X? Negative 1 and positive 8. So how do we say that using
Wonder
interval
if this will be
notation?
smart enough by the time we retire. Well, they have the problems where you type in all real numbers except negative 1 or positive 8.
I think they do. I think they could already do that if they wanted to.
But I guess
was
if a
reading the
student-
story about the student with the Grammarly. Did y'all read that?
Oh no, was it
some
good?
way out of state student that got into trouble for using Grammarly on her paper when the college websites require students to use that app for their writing assignments. The college website says, here's a tool that you can use. Y'all use Grammarly? No? I've never used it. I don't have to write, well, I do write papers. I write program reviews, but
Okay, so what are we going to put at the negative 1 and 8 to indicate that we're not including them? Would be open circles. So it's everything except, and I'm just drawing this graph to help me get the interval notation, because the interval notation needs to be written the way you see it on the number line. I'll get started. Parentheses, I'm doing this first one. Negative infinity, comma, negative 1, parentheses, union, parentheses,
What's
Negative
in it?
1, comma 8.
negative 1, comma 8, parentheses, union.
8, comma infinity.
Mm-hmm.
Parentheses.
Everything's parentheses, no
what is
brackets.
this interval here saying? It looks like an ordered pair, but what's it saying in terms of interval notation?
All real numbers except for negative
Well, the whole
That's what
thing
the
says.
whole thing is saying. I'm talking about this little middle part. That's describing what part of the numbers. All real numbers between negative 1 and positive 8. Okay.
Okay, type it in real fast. We're eager to go, Tim.
Okay.
We want today to be over because then they only have one more class period before spring break. And I guess I need to put this get it recorded. Spring break is only 1 week, not
And
2 or 3 weeks, okay? If you're going to take off extra weeks after spring break, you still got to do your math work, okay?
Now, if you want to do that, there is a student in my class that I think they're ready to take the final in this class. They're going through and they're ready to take the final. But then again, there are also 9 students that have not done the review for quiz 1. And that's disturbing because you can't move forward. Remember, everything has a prerequisite. So if you're one of those students in my class, Precella, 9 students as of yesterday
Oh my
had not
gosh, Tim.
taken the review, done the review
I would
for
not
quiz
record
1.
that, Tim. Oh, wow. Okay, I'm going to end this.